Let's check this one. This time we have this claim, fewer than 30%. So if we want to translate the sentence into an expression, this is still about the proportion, right? Fewer than 30%. So fewer than 0.3. 0.3. After we got the expression, we still need to determine if this is the non-hypothesis or alternative hypothesis. We know it must be one of the hypotheses. So this time, inside the middle, it's not equal sign. So we will say it's our alternative. And we can write our none. Only need to change the sign in the middle to be an equal sign. So that will be our none and the alternative. So let's check the alternative here. P is less than, so it's still one tail test, but this time we're talking about left tail test. Left tail test. So by this step, we already have none and alternative, and also know we are doing the left tailed test. Of course, we can quickly go through the requirement check. So symbolic form. So after that, we should list what is our none and what is our alternative. I will list this is left tail test. Step 4, we know the question already set the alpha level. Step 4, we're going to find what is the test statistic. If we use technology, we know the test statistic here is this one. And we can automatically get the p-value. But if we use the formula, we're going to use this formula, right? Again, p hat is the sample proportion here. We use x divided by n. X divided by n to get the sample proportion. It's from your sample. And how can we get 0.3? It's from your non-hypothesis. It's from your non-hypothesis. The assumption said p is equal to 0.3. So after that remaining part, we just plug it into the numbers, but make sure the denominator is not p hat q hat. It's the p and the q. Remember, when we do the confidence interval in your formula, you will have p hat times q hat. But to do the hypothesis test, it's p times q, okay? Don't mess them up. So I will get this as our test statistic. So if you use this test statistic, negative 2.41, to check your negative z table, you will get this value. So negative z. Of course, negative value is left to the middle, right? So you already get the left tail p-value. So that value directly from your table is your p-value. If we use p-value to compare to our alpha value, we know this one is less than, right? Is less than 0.05, our alpha value. So p is low, none must go. We reject the non-hypothesis. So we reject the none. So we think it's not equal to 30%. We will say there is sufficient evidence to support less than. This is our alternative, right? We will say sufficient evidence to support less than 30%. Have sleepwalked. So this is the last step. Try to write your non-technical conclusion. So this is generalized how we find the p-value. If it's left tail test, the p-value directly from your table, actually. You will get a test statistic. Then use that test statistic to check the table of Z table, to find the corresponding area. That area, cumulative to the left, is just the p-value of your left-tailed test. But for the right-tailed test, you will get a test statistic Z, right? Check the test statistic Z in your table. You will find a value. But you should use that area to the left, subtract from the total area to get the right tail, because this area is always the left side. If it's two-tailed test, so you should get one tail, the area of one tail. Then double it times 2. That will be your probability value. Sometimes you will get the area of the left tail. Sometimes you will get the area of right tail. Okay? But don't forget, for the two-tailed test, you need to double one tail probability to get the p-value for two-tailed test. So another method called exacting method, then we will quickly skip this one because we should use the technology to do this method. It's impossible to use the table to do that. So let's say we just stop here. We only need to know how to use the test statistic. So that method based on the normal distribution as to approximate the binomial distribution. So we do not talk about the exact method. This one is based on the technology. So we only need to know the p-value method, critical value method, know the whole procedure, how to use these two methods to get our conclusion.